the tangent and normal. How to find tangent and normal? The important thing is to make sure the point given is actually on the graph. Make sure it's the contact point. Otherwise, we'll use this method to do the question. Today we do still a revision class, which is the rate of change and average rate of change and instantaneous rate of change. So there are two types of rate of change. So what is average rate of change? The average rate of change must be talked in between 2 points. Okay, it must be talk about the average rate of change in between 2 points, or giving you a period of time. Okay, from this time to this time, it must talk about there must be 2 endpoints. Okay, what's the average of change between 1 p.m. to 10 p.m.? Must talk about 2 points. You can't say what's the average of change for x equals to 4. You can't talk about the average. So average of change is in between 2 points, and the formula given is actually the gradient formula. Okay, how to find gradient in the linear? You use y2 minus y1 over x2 minus x1. Is how you find the gradient in between those 2 points. If you connect those 2 points by linear, how do you find the linear for the gradient for that linear? So what is average rate of change? Say let's say we have a curve like that, and then we have 2 points. Let's say what's the average of change between t1 and t2? Okay, doesn't matter. Okay, so you don't need to worry about what happens in between. You just need to see the final value and the starting value. So we have start value higher than the finished value. So we connect those 2 points. The average rate of change equals to the gradient of that linear. Okay, so which is y2 minus y1 over x2 minus x1. And instantaneous rate of change. Instantaneous rate of change is only talk about 1 point. Okay, you won't say average rate of change for 2 points. It's only 1 point. Give you 1 pointer. So give you 1 point to say what's the instantaneous rate of change at that point, which is the derivative. Okay, find the derivative and substitute that point in. So basically, it's talk about the tangent of tangent's gradient at that point. Okay, so what's the instantaneous rate of change? Is the gradient of the tangent, okay, at that point. So if dy dx greater than 0, the change is increasing, okay, have an increasing graph. If dy dx smaller than 0, which means it's a decreasing graph. So y value is decreasing corresponding to the increase of x. Okay, let's have a look at the example. Example 1. For the function with rule fx equals to x squared plus 2x, find the average rate of change for a period of time. See x in between 2 and 3. You don't need to worry about what happens in between. You just see the starting point and finish point. So when x equals to 2, when x equals to 2, f2 gives you 2 squared plus 2 times 2, which gives you 8. Okay, 2 squared is 4, 4 plus 4 is 8. When x equals to 3, that's the finish point, f3 is 3 squared plus 2 times 3, 9 plus 6 gives you 15. Okay, so average rate of change equals to f3 minus f2. Okay, the two y values subtract each other and minus the the difference between the x. Okay, so 3 minus 2. That gives you 15 minus 8 over 1, and is 7. And is 7. So the average rate of change is for every for 1 x increase in 1 unit, the y value will increase 7 units. That's the meaning of average rate of change. In average, for x increase 1 unit, y will increase for 7 units. Okay, the next one is Find the average rate of change for the interval 2 and 2 plus h. So you have h, which is unknown. So you assume like you know h. H take different values, you have different y values, and you have different average rate of change. So we'll find f2 plus h first. f2 plus h first. Okay, what is f2 plus h? So it's 2 plus h squared plus 2 times 2 plus h. Okay, let's expand that a little bit. That gives you 4 plus 4h plus h squared plus 4 plus 2h. And that gives you 8 plus 6h plus h squared. Okay. Check it. 8. Yep, that's correct. And f2 gives you 8. You know that f2 gives you 8. So the average rate of change is f2 plus h minus f2 over 2 plus h is the x value minus 2 is the x1 value. So what you will have is, okay, f2 plus h is that. f2 is that. They subtract each other, the h just cancelled. So we have 6h plus h squared over h. And that value gives you 6 plus h. Okay, 6 plus h. So the average rate of change is 6 plus h. So for every 1 unit increase in x, y value will increase 6 plus h units. Okay, now it asks you to find the instantaneous rate of change for f with respect to x when x equals to 2. Okay, if when x equals to 2, what you're trying to find in this case is the instantaneous rate of change. If it's the instantaneous rate of change at x equals to 2, then what you're trying to find is f dash 2. Okay, it's the gradient of the tangent, which is the derivative, and you substitute to it. But we can do a simpler way, like you can do 2 ways. You can find f dash x first. Okay, find f dash x first and substitute x equals to 2. But remember, B and C must got some connections between each other. Okay, I can say 2 and 2 plus h. There must be some connections between each other. So you will, in some case, it will say hence. Okay, in this case, you can do both ways. You can find f dash x and put 2 in. But if the question says hence, find the instantaneous rate of change at x equals to 2, you cannot find f dash x and substitute 2 in. You must use the answer for the previous question. Use that answer. So how we can use that answer? Remember at the very beginning what we learned for derivative. What's the meaning of the derivative? Okay, it is lim h approaching to 0. You want to find f dash 2 is f2 plus h minus f2 over h. Right? That's the definition at the beginning what we learned for derivative. If we want to find f dash 2, okay, that's the similar to first principle. What is first principle? Just do a little bit revision. F dash x equals to lim h approaching to 0, fx plus h minus fx over h. That's first principle. But if you try to find one particular point of the derivative, you can directly change the x into the number you're trying to find. In this case, we want to find f dash 2, which is the lim h approaching to 0, f2 plus h minus f2 over h. Okay, why is easier to use this way? What is f2 plus h minus 2 over h? Is this. Okay, is that. What is that? That is 6 plus h. No, that is 6 plus h. You just work it out for the previous line. That is 6 plus h. And h approaching to 0, not in the denominator. You can directly do the substitution, which gives you 6. So f dash 2 is 6. It will be the same like if you do f dash x and substitute 2 in. Okay, if the question says tens, you must use this method. Okay. So this is not a hard question, it's pretty easy, but the thing I want to say is that last question. Okay, when you see 2 and 2 plus h as the interval, you will start to think about, yeah, next question will be instantaneous rate of change. You can predict the question. Otherwise, why I put the h here? The h is ask you to do that. Okay, limit h approaching to 0. Okay, that's first example, and let's have a look at second example. A balloon develops a microscopic leak and gradually decreases in the volume. So the volume is decreasing. So you must have, if you do dV over dt, it must got a negative value. Okay, it's a decreasing value. What is the average? Okay, you have VT graph like that, VT equation like that. What is the average rate of change for the first 10 seconds? Okay, be careful. In this case, you can only see one number, which is 10. But the description is the first 10 seconds. Okay, it's not only at the point 10, it's for the first 10, which means t belongs to 0 to 10. Okay, for the first 10 seconds, it's actually talking about an interval. Like, you won't always see two numbers. Some case you can only see one number, but it's actually talking about the interval. Like they always say, like the first 10 seconds, or for the second 5 seconds, like your first 5 seconds, second 5 seconds, you're from like 5 to 10 seconds. Okay, so for the first 10 seconds is 0 to 10. Find the average rate of change. So you will find when t equals to 0, v equals to, okay, 0, 0, you have 600. When t equals to 10, v equals to 600 minus 10 times 10 minus 100 times 10 squared. So 500, that's 500 minus 1, so 499. Okay, 499. So what is the average rate of change? That equals to V10 minus V0 over 10 minus 0. That equals to 499. Okay, remember, must be the last value subtract the first value. You can't do V0 minus V10. Okay, we can't do V0 minus V10. But like you have the same answer like in the end. But try to write in the correct order. So it's the last value subtract the beginning value, divide by 10. That is negative 101 over 10. That gives you negative 10.1. The unit will be centimeter cube per second. Okay, negative 10.1 centimeter cube per second. If asked you to explain this answer, you won't say the rate of change is negative 10.1. You will say the decreasing rate is 10.1 centimeter per second. You say the decreasing rate. Volume is 10.1 centimeter cube per second. The negative is not always there. Okay, if I ask you what's the rate of change and explain your answer, you can't keep the negative there. The negative doesn't make sense. The negative only tells you it's a decreasing or like reduce or something like that. So you need to emphasize it's a decreasing rate. You can't just put negative 10.1 there. Okay, find the rate of change. It doesn't say what kind of rate of change. After 10 seconds. Okay. After 10 seconds, you will say directly after 10 seconds, what is the rate of change? Okay, that's the instantaneous. It's at that minute, that second, what's the rate of change? It's the instantaneous rate of change. Because you can't really write the interval out. What's after 10 seconds? Okay, it will be at a single point. It's the instantaneous one. You think whether I can find the time interval. If I can't, that's the instantaneous rate of change. So basically you need to find v dash 10. So let's find v dash t first. V dash t is negative 10 minus 1 over 50 times t. Okay. If you derive that, 600 becomes 0, negative 10t is negative 10 minus times 2 is 1 over 50, and subtract 1 on the power, which is 1 over 50t. So v dash 10 gives you negative 10 minus 1 over 50 times 10. That's negative 10 minus, okay, 10 times 1 over 50 is 1 over 5, which is 0.2. So that is negative 10.2 centimeter cube per second. Same, if asked you to explain your answer, you say the instantaneous decreasing rate at t second is 10.2 centimeter per second, to centimeter cube per second. Okay, the last question, it says, for how long could the model be valid? Okay, that's a like really general question. It's not really related to rate of change. So the model needs to be valid. It's like kind of application question. You think about what can be true or can make sense. The volume can't decrease to a negative value, and you can see that's a quadratic equation. Okay, that's a quadratic equation. So you will say it's valid in between t greater or equal to 0. You want to find the time that can make t greater or equals to 0. Let's say the graph will be a decreasing graph because t squared is negative. So you will find those 2 points first. Okay, you will find those 2 points first, which is when v equals to 0. So minus 100t squared minus 10t plus 600 equals to 0. That's times negative 100 is t squared plus 1000t plus 6000 minus, okay, times negative. So it's a minus, and 0 times that is still 0. Okay, and let's find the discriminant. The discriminant is 1000 squared plus 4 times 1 times 6000. It's a really big number. Okay. How many zeros are there? 1, 2, 3, and I have 4, 2. So that equals to 1024,000. 1024,000. Okay. And what's the square root of that? So that first I can take a 10 out. 10240. Okay, it's 10 times 1024. Find the 4 out. That's 1, 2, 5, 6. Find another 2 out. 7, 8. So I can divide by 4 here. 39. And then it's 3 times 13. Can't do anything. 2, 5, 3, and 13. So I can't do anything to that. So I have 2 4s. That I can take another 4 out. That gives me 40. Square root of 390. Okay, 390. That's the discriminant. Okay, that's what I'm doing. Then what t equals to? T equals to minus b plus minus square root of b squared minus 4ac over 2a. Okay, divide by 2. So that equals to minus 500 plus minus 20 square root of 369. Okay, one number is positive and one number must be negative. You can't have your time be negative. Okay, you can't have your time be negative. Your time can only start at 0. So you won't take the negative value. So your valid time will be t belongs to 0 until minus 500 plus 20. Right in red, t belongs to 0 to minus 500 plus 20 root 390, close bracket. If you have cast, like, I think in VCA exam, it will be a cast aloud question and we'll ask you to simplify and like round to 2 decimal places. Won't ask you to keep the exact, but like you should have the ability to do this kind of question by hand. Okay, so I'll just do a little bit calculation here. Normally this type of question will be corrected to decimal places. But it doesn't say in this question, so you can't round it. You must keep the exact values. Okay, so that's 10b, average rate of change. Have a look at 10c. 10c and 10d talk about this together. Is stationary points and types of stationary points. So let's have a look at this graph. Let's have a look at this graph. Okay, let's, I want you to extend this graph for me a little bit, just extend a little bit longer. Let's say the endpoints is here, and I have endpoints here. Just go above A, okay, above this horizontal level. Okay, go above that. To where doesn't matter. Okay, let's talk about the name. I think you all learned that last year. Let's talk about the name. What's the name of A? What's this A called? What maximum? I have 2 types of maximum. Local maximum. Local maximum turning point. What is B called? Yeah, stationary point of inflection. What's the C called? Local minimum. Any other names here? It is also the minimum point, like the lowest point in this graph. So this is also the absolute minimum. In this case, okay, in this case, it's also the local minimum. It is, and also the absolute. It's also local and absolute minimum because it's the turning point and it's also the lowest point in this graph. Okay, what's this point? Let's call this point A, B, C, D, E. What is this E? What's E? Absolute maximum. Okay, it's the highest point in this graph, so it's the absolute maximum. How about this D? What's this D? It's called the endpoints. It's not maximum, it's endpoints, and this is also the endpoint. Okay, it's 2 endpoints, but like it's not maximum or minimum because it's not the lowest or highest value, and it's not the turning point, so it's the endpoints. Do we have gradient at that point? No, can't derive at that point. Okay, so the derivative of a function gives this gradient function, and it gives the gradient of the tangent. Okay, it gives the gradient of the tangent. F dash x gives you the gradient of the tangent, as what we learned last lesson. So A, B, C, can see that 3 lines actually 3 tangents. Okay, the A, B, C, the horizontal line is actually 3 tangents line. So that 3 tangents line should have gradient of 0. Okay, therefore, for stationary points, they all call stationary points. Okay, but like A and B called turning point, and that is point of inflection. They are all stationary points. A, B, C are all stationary points, and they all have gradient equals to 0. Okay, the f dash x equals to 0. So stationary type, let f dash x equals to 0 and solve for x. You have stationary point of inflection and you have turning point. The turning point have local maximum point and local minimum point. Okay, so 3 types. So types of stationary points. So that's the box, like a box. We draw a box. When you solve f dash x equals to 0 and you have, for example, x equals to 1, x equals to 2, and x equals to 3, you don't know which point is turning point, which point is the stationary point. Even though you know that all turning points, you don't know which is the maximum turning point and which is the minimum turning point. And you use this table to help you to work out what is the maximum and what is the minimum and what is the stationary point of inflection. So if you have gradient box like increasing, horizontal, and decreasing, you have local maximum, and that's a turning point. If you have decreasing, stationary, and increasing, that's a local minimum. You have increasing, stationary, increasing, that's a stationary point of inflection. You have decreasing, stationary, decreasing, that is the stationary point of inflection as well. So you have those 4 types of graph to decide which type of the stationary point it is. Okay, let's have a look at example 1. Let's have a look at example 1. Find the stationary point, state the nature of the point, and sketch the following function. Okay, so let's sketch it. First, let's find the derivative. Let's find the derivative. Dy dx. Okay, dy dx equals to, what dy dx equals to? How do we derive exponential function? Three x squared, yeah, times itself. Okay, times itself. Okay, and then we think about dy dx equals to 0, right? We want to find stationary points, so we will make dy dx equals to 0. So it's 3x squared times ex to the power 3 equals to 0. How do we solve this equation? How do we solve this equation? Not by calculator. Okay, can you see that's 2 function times together, and we use non-factor law. If something times something equals to 0, we always think about the non-factor law. So that is, left is 1 function, right is 1 function. If you can make this equals to 0, or you can make that equals to 0, you can have 0 in the end. So this equals to 0, which is easy, just x equals to 0. How this one can become 0? Can that become 0? No, exponential. Exponential of anything cannot be 0. Okay, exponential to any power is not going to be 0. What's the exponential function looks like? You have asymptotes here, and that's your exponential function. Doesn't matter what looks like what's the whole function looks like. If the base is something and to a power which include x, that's not going to be 0, because you have no value can make exponential to become 0. So no solution here. Which means you will only have 1 stationary point. You will have only 1 stationary point. When x equals to 0, if it's a stationary point, you need to find out the y value. So when x equals to 0, y equals to e to the power of 0, which equals to y. So 0, 1 is the stationary point. but I don't know whether it's a maximum, minimum, or stationary point of inflection. So now I will use this box to do it. So how we make this box? We will have 3 rows. The first row is x, f dash x, and the last line is graph. You always leave the first one empty, and you put the smallest stationary points, x values, which is 0 in this case. Okay, you may have more than one value, so you put the smallest one here, and you will leave another space. Okay, leave another space, and you can put the second smallest number for the stationary points. But in this case, we don't have, so we just have 4 columns here. Okay, we will write 1 point to the left of 0. I can choose any point, but like -1 is obviously a good one, so I'll put -1. And I'll put another one like 1. Okay, just choose any 2 to the left and to the right. Okay, you know that f dash 0 equals to 0. Okay, write 0 here. That already be 0. And what f dash -1 gives you? Okay, what's the gradient at x equals to -1? So let's put -1 into this. Put -1 into that. You don't need to really calculate the value out. You just need to tell me whether you have a positive or negative value. Whether you have a positive or negative value. Have a think about that. Positive or negative, if you put -1. 3x squared, you put -1, it must be a positive, right? And exponential must always be positive. Exponential of anything needs to be positive because the graph is here. Exponential of anything is positive. So you have a positive value here. Just write a plus. And if you put 1 in, what do you have? Positive. Like that. Okay, increase 0 and increase. So what that point will be? Stationary point of inflection. Okay, at 0, 1, that's a stationary point of inflection. Okay, now I want to sketch this graph. This graph is a really unfamiliar graph. To sketch an unfamiliar graph, what we need to do is, okay, write this down. This is quite important. You may ask to sketch some unfamiliar graph in the test. So first is, okay, let's write in the collection, unfamiliar graph. First, find xy intercept. Second, find stationary points. Three, state the nature. So whether it's maximum or minimum. 4, talk about the behavior for y. Okay, behavior for y value when number 1, x approach to -infinity. Second, x approach to +infinity. Okay, you think about the behavior, -infinity, +infinity. Oh, sorry, I forgot something. 0, number 0 is domain. Okay, you will think about domain first. Whether anything I can't take or I can take, what I can take, is that domain R or domain 0 to infinity, or like -infinity to 0. So think about domain first, and then xy intercepts, and find the stationary point, state the nature, and when you state the nature, you can see the trend of the graph, right? Near 0, your graph will be looks like that. Okay, near 0, your graph will look like that. You can see the rough shape of your graph. And then you will think about the behavior for y values when x approaching to -infinity. When your x get really small, what your value will approach to. And then the next thing is when x become really big, what's the trend of the final graph? like to positive infinity. Okay, let's think about the domain for the first one. Okay, domain. Okay, number 0, what's the domain can be for this graph? What do you think the domain will be? Is there any other restrictions? No, so R. Okay, first, xy intercepts. Will there be x-intercept? No. When y equals to 0, exponential cannot be 0, so no x-intercept. And y-intercept is when x equals to 0, which is 0, 1. Okay, when x equals to 0, y equals to 1. So 0, 1 is the y-intercept. Number 2, find the stationary points. The stationary points is 0, 1 already. And number 3, state the nature. The nature is stationary point of inflection already. We work out all of that. Number 4 is the most important step. Think about the behavior. Let's say when x approaching to infinity, what y value will approaching to? Think about if x get really, really big, what y value will it be? Infinity. Okay, we'll get really big as well. So we're approaching to infinity. When x approaching to negative infinity, y value will approaching to what? Let's think when you get a really negative number, negative 10,000, and you cube it, it's negative 10,000 to the cube. It's still a really, really negative and large number. And exponential to a really, really large negative number, what that will be? 0, approaching to 0. Okay? When x gets to negative infinity, your y value will approaching to 0. And near the stationary point of inflection, your graph will be somehow like that. You have a stationary point of inflection near the stationary points. Okay, let's put all of this information in. When y approaching to 0, it means you will have asymptotes at y equals to 0, right? You have asymptotes. So you have asymptotes here. And you have 0, 1. Let's say 0, 1 is here. It's too high. Let's make it lower. Let's say 0, 1 is here. Okay, to this end, you have graph really tall, like up here. To this end, you have like asymptotes, right? Approaching to 0 to the negative end. And you have stationary points of inflection there. So you can think about your graph. Okay, let's do it. See the graph? This roughly looks like that, which is not a perfect graph, but it makes sense. Okay, you have a stationary point of inflection there, and you have a really increasing graph. Okay. And that is 0, 1. That is y equals to 0. Okay, can you see it does make sense? Because to the lower end is approaching to 0, and to the right hand side is go to positive infinity. And this point is a stationary point of inflection, and it has y-intercept here. There's no x-intercept, and the domains are. Okay, satisfy all the things we have just right. Okay. That's this one, and let's have a look at the next graph. Okay, first I want to state the nature of the find the stationary points. Find the stationary points. So what is dy dx? Okay, what rule I will use to derive this equation? Okay, chain rule, product rule, quotient rule, which rule we use? We can use chain, and we also need to use another one. We don't really need to use chain rule here. Product rule. Okay, it's one function times another function. It's x times log x. That's two types of equation. Can you see that? X is polynomials and log is log. So that's two types of functions. So you need to use product rule. So let's say ux equals to x, then u dash x equals to 1. Vx equals to log e to x. Then v dash x is 2 over 2x. Okay, 2 over 2x. G dash x over gx. G dash x is 2, gx is 2x. So 1 over x. 2 over 2x is 1 over x. So dy dx equals to u dash x times vx, v dash x times ux. So cross times them. So you have x times x, 1 on x, you have 1. Plus log e to x. Okay. X times that is 1 on x is 1. So 1 plus log e to x. And you make that equals to 0. So log e to x equals to -1. 2x equals to e to the power of -1. And x will be a half of that is 1 on 2e. Okay, 1 on 2e. Okay, if that equals to 1 on 2e, what y equals to? Y equals to 1 on 2e times log e times 2 times 1 on 2e. Y equals to 1 on 2e times log e to the power of -1. Right? 2 times 2 is 1, 2 times a half is 1, so it's 1 on e is e to the power of -1. So y equals to -1 over 2e. Okay, that minus go to the front and log e is 1. So it's -1 on 2e. So the point is 1 on 2e, comma, -1 on 2e. Okay, now I need to state the nature of this. I still need 4 columns. You have x, f dash x, and the graph. You have 1 on 2e in the middle. You have derivative equals to 0. Let's choose a point to the left to that. 1 on 2e must be a positive number, right? Must be a positive number. Then what I have is 0 here. I can choose 0 here. And let's put 0 into the derivative. You can't choose 0. You can't choose 0. Why you can't choose 0? Your domain is like greater than 0. Can't choose 0 because you can't put 0 into log e. If I can't choose 0, I will think about to choose the number wisely because, okay, why? Because if I choose a number like 1, okay, like that's a number less than 1. Okay, so that's 1 over 2 times e. What is e? E is 2.7 something. So it's actually 1 over 5.4 some number. Like it's a 0.2 near 0.2, like less than that. So, okay, I will choose a number like okay, I will choose a number like that. I increase my denominator. Okay, I increase my denominator. If I increase my denominator, I still maintain this e. It's easy for me to substitute that into log. Okay, still a number smaller than that and easy for me to calculate. If I put like 0.1 there. I don't know how large is that. I can't really state whether it's positive or negative. So this is a good number to try. Okay, and I will put another number in it. Let's put e over 2. It must be a greater number, right? E over 2 must be a number greater than that. Okay? And then I can easily do the substitution. So what is f dash x? F dash x, f dash 1 over 2e2 equals to 1 plus log e 2 times 1 over 2e to the power of 2. That is 1 plus log e to the power of negative 2. That equals to 1 minus 2 equals to minus 1. That is a negative number. F dash e over 2 equals to 1 plus log e 2 times e over 2. That is 1 plus log e. And that is 2. That is a positive number. Negative, 0, and positive. It is a minimum value. Okay, this question, the hard point is how you can choose two values to the left and to the right can make the calculation easy. Okay, how you can make the calculation easy. If you choose a pure number like 5 or 2 or 1, like you can't really find an easy calculation. Well, actually you can put 1 here. Okay, you can put 1 here, it doesn't matter. If you put 1 log e, oh, you can't put 1. You can put a half. Okay, you can put a half there. The half will be alright because log e 1 gives you 0. But anyway, I worked out that's a minimum turning point. Okay, it's a minimum turning point. State the nature is a minimum turning point. Okay, I don't have enough time to continue. I'll ask you to think about what's the shape of this graph. Okay, think about what's the shape of this graph.